In this example, we have Professor Smith managing his lunch budget. His budget is $100 per month. And he can go eat at the faculty club, which costs $5. And if he exclusively eats at the faculty club, he can go there with his $100 budget, he can go there 20 times. He also has the option of eating at the levy, where each lunch costs $10. So with his $100 budget, he can eat at the levy up to 10 times. So let's draw a budget constraint, which is really just an application of a production possibility frontier that demonstrates the options that Professor Smith has. So on the y-axis, we'll put faculty club lunches. On the x-axis, we'll do lunches at the levy. So we just calculated that at most he can go to the club 20 times. And at most he can go to the levy 10 times because it's twice as expensive. And there's a constant 2-to-1 trade-off between the two. So we draw a straight production possibility frontier, or in this case, we would just call it his budget constraint. Next, we will write an equation that describes this budget constraint. So we can write it this way. We can say, okay, at most, the number of times that Professor Smith can eat at the faculty club is 20. And then every time that he eats lunch at the levy, he's giving up 2 lunches at the faculty club, right? The levy costs twice as much, so each time he eats at the levy, that's 2 times he could have eaten at the club. In other words, 1 levy lunch is equivalent to 2 lunches at the faculty club. The next part of our question asks, well, if Professor Smith chose to eat at the club 10 times and at the levy 5 times last month, does this fit within his budget constraint? So there are really 2 ways that we can answer that question. Is this combination of lunches affordable for Professor Smith? One way is to say, okay, well, if he eats at the club 10 times, each of the club lunches is $5. And if he eats at the levy 5 times, each of those lunches costs $10. And so that ends up being 50 plus 50, or $100, which is exactly Professor Smith's budget. And so yes, this combination of lunches is within his budget constraint. It exactly spends his budget. Okay, so if we were to draw that, we would see that this combination lands us exactly on the line, not outside of it, which would be beyond his $100 budget, and not within the line, which would be less than 100. He wouldn't be spending his entire budget. The other way to answer this question is to use the equation for the budget constraint. So we can plug in either 5 for the levy in this equation, or we can plug in 10 for club in this equation, and then solve the equation to see what is possible. So let's say we plug in for L. So we take the equation 20 minus 2 times 5 levy lunches. So if Professor Smith goes to the levy 5 times, okay, he could still eat at the club 10 times, which is exactly what he's done, right? He's eaten exactly 10 times. So yes, this is all possible within his budget constraint of $100. All right, the last part of the question, part D, asks or gives us a scenario saying, well, last month the levy ran a half-price lunch special all month. So instead of $10, each lunch at the levy cost $5. So what is the effect on Professor Smith's budget constraint? Well, now at half price, he could afford to go to the levy double the amount of time. So his $100 budget at $5 per lunch would allow him to go to the levee 20 times. Okay, so if we draw that, we've expanded from 10 out to 20 possible lunches at the levee. Professor Smith's budget constraint has shifted out along the x-axis, right? And now the trade-off between club lunches and levee lunches has changed from 1 to 1. So 1 club lunch equals 1 levee lunch versus before 2 club lunches equaled 1 levee lunch.